Hello everyone. I am G. Karthik, working as an assistant professor in Congrad College of Engineering and Technology, IT department. Today I am going to take about multicasting and multicast routing protocols. So what is multicasting? So multicasting means there is only one sender and then multiple receiver. So I'm going to transfer the data from only one sender. So but it would receive the data in a multiple units. And that is we call it as a multicasting. In multicasting there are so many types are there. The first type is called as a unicasting. So what is unicasting? The unicasting, the router forwards the received packets through only one of its interface. So that is we called as a unicasting. So in this diagram, see here, there is one source and then only one destination is there. I'm going to transfer the data from a source to destination. So only one side itself. We can't able to transfer the data from a destination to source. So that is we called it as a unicasting. The relationship between the source and destination is only one to one. So next one is multicasting. In multicast communication, there is one source and then group of destination. This thing we told. So only one source and then group of destination. So one router may forward the received packet through several of its interfaces. We call it as a multicasting. So the example is there. So in this diagram, so one sources is there. The so much of our routers is there. With the help of the router, I am transfer the data to so multiple destinations. So that is we called it as a multicasting. So with the help of this routers, intermediate routers, we will duplicate the sended information. That information to be transferred to the multiple destination. So that is we called it as a multicasting. So next thing is multicasting versus multiple unicasting. We already know about multicasting. In that multicasting, we having only one source and then multiple destinations are there. With the help of the router, we can duplicate the packet and then transfer the data to multiple destinations. That is, we called it as a multicasting. But in this multiple unicasting, I am transfer multiple packets to multiple destinations. So that much of transmission is that not that much efficient, because so multiple packets are transferring simultaneously to multiple destination means, so at the time definitely the delay will occur. So due to the delay, the multiple unicasting is not that much sufficient compared to the multicasting. So that is a difference between this multicasting versus multiple unicasting. So multicast applications. In what are all the ways we can utilize this multicasting? That is the thing we are going to see. See there is one to many. So one to many means we can use it for lecturers and then business TVs. Okay, scheduled audio and then video distribution, and then push media. So we can feed the news headlines to multiple systems, and then weather updates and then radio broadcast. The next thing is file distribution and then catching. So file distribution is that the website content we are so transferring to multiple destinations, and then file based updates. So next thing is announcement means network timing and then session scheduling, and then monitoring stock prices and then telemetry. So stock prices we already know. So each and every frequent of time, and they are updating their prices in stock markets, no. So that kind of examples which is related to this multicast applications. And then many to many. So the many to many means multimedia conferencing. So multimedia conferencing is that only one source is there and then multiple destinations in remote area they are watching audios and videos. So that is one example for multimedia conferencing. And then synchronized sources, so distributed database example. So distributed database is that this for this also we having one sources and then multiple destinations are there. In multiple areas they can access the information from a single source. For example, take it as a cloud. So in cloud, we are updating the database in a variant side. If any one of the user want to access from the cloud means, so we need to get permission from the concerned authority, and then with the help of that key we can access the data from a cloud. So this is we call it as a synchronized sources. And then concurrent processing is called as a distributed parallel processing. So for this, so a lot of examples is there. For example, take it as a student's project. They are doing the projects. The four members doing project means each and every one of them they having one module. They are done parallel work together, and then finally they are combined together as a single project. So this kind of thing we call it as a parallel processing. For example, I'm telling, so working parallelly, so each and every modules to be split up together and then work together, and then finally combined it as a one process. We call it as a distributed and then parallel processing. We are distributing the process to multiple users and then working frequently, and then finally we can combine together as a single project. We call it as a concurrent processing. And then collaboration, sharing document, and then editing. So we are the user, we are sharing the document to multiple users, and then we give the permission to edit our document, and then they can use that kind of process. We call it as a collaborations. And then distance learning, one to one, and then feedback. So we are uploading our videos so through YouTube, and then we are taking classes through Google Classrooms. uh, so this kind of examples are suitable for distance learning and then chat groups. So these all applications are related to the multicast applications. So next one is shortest path tree. The shortest path tree is that group of nodes are combined together. So out of that group, we need to identify which one is the shortest route to reach the destination. So within this group, the routers are there. With the help of the router, so we already know router is to identify the shortest route to reach the destination for transferring the informations. So that is use of this router. So each and every node have their own table, routing information table. So with the help of the table, we can identify the shortest route. So each and every node have the distance of another node. So with the distance, we can identify the shortest distance. With the help of that distance, we can identify which one is the shortest route to reach the destination. See here, there is a routing information table is there. In the table, all nodes informations are available. So with that all in node informations, so each in for suppose I'm transferring the data means for each and every node, the routing information table will be updated frequently. So before we have seen one diagram, with the diagram they are explaining briefly. So every group member should receive only one copy of a sent packet. Suppose in a group we having five nodes means, so each and every node they send the packet only one copy alone. So it should not send the duplicate copy multiple times to the corresponding node. The non-members are must not receive a copy. Suppose the corresponding node is not a member of the group means that node will not receive the request. A packet must not visit the router more than once. So no loop should not occur. The deadlock will not occur. So that only they are mentioning. So in a group they are having five nodes means, so the loop will not occur. If loop occur means definitely the data loss will occur. So that should not happen. The paths from a source to destination must be an optimal. Anyhow we are transferring the data, so we are choosing the best path for transferring the data. Best path means which is the shortest path, we call it as a best path, that is an optimal path. Source based shortest path tree. In this source based shortest path tree, each router needs to have only one shortest path for each group. So that only they are mentioning in this source based shortest path route. So from a source means that which one is the where we are initiating to start to send the data. So that one is we call it as a source. From the source, so which one is the shortest distance for so reaching the destination? For example, I'm having the group member for R3 router 3. I'm having the group of G2, G1, and then G4. So like that, each and every router having the certain group. So based on the group, I can transfer the data. That type of thing we call it as a source based shortest path route. So group shared shortest path route. Next one is group shared shortest path tree. So in this group shared shortest path tree, only core router which has the shortest path tree for each and every group, which is involved in a multicasting. Here in this group, the core router is there. So in this core router only, we are start to transfer the data. The core router having information about the all remaining routers. So whatever information I want to search, so I can search from a core router. So within the router itself, I can identify which router belongs to which group. Like that, I can identify. So within this, so multicasting topic is over. So thank you for all.